in section 8.4, we'll take the polynomials that we were working with previous to this lesson and we'll actually turn them into equations. If you think back, none of the problems we were doing thus far in this chapter had equal signs. So we're going to take those polynomial equations and actually solve them this time, and the way we do that is by getting them into factored form, and this is the part that will be new to you. So to start this section, I'm going to pose a question to you. If A times B is equal to 0, then what can you conclude? So think about it. If I have two numbers multiplied by each other and I get 0, that means that either A equals 0 and or B equals 0. Because if I put 0 in for A, I would get 0 times B, which is equal to 0, since 0 times any number is always equal to 0. If I put 0 in for B, I would get A times 0, and of course that would equal 0, since any number times 0 gives you 0. If both numbers are equal to 0, 0 times 0 is still equal to 0. So whenever I have a multiplication problem set equal to 0, I know that either both or one of them is equal to 0. This is the underlying property that we are going to use going forward in the rest of this chapter. That property is called the zero product property. I think of it this way. We need to set our equation equal to 0, so that's the 0 part. We need to turn our equation into a multiplication problem. Remember, the answer to a multiplication problem is called a product. So we have set it equal to 0, turn it into a multiplication property. So again, it states that if A times B is equal to 0, then either A equals 0 and or B equals 0. Again, the zero product property, set it equal to 0, turn it into a multiplication problem. That is going to be the underlying property that we are going to use over and over in this chapter. So now we're going to take the idea of the zero product property and apply it to the following example. So here in example 1, it says solve for x. So for part A, notice it says x minus 4 times x plus 2 equals 0. So notice we have an equation set equal to 0, and the equation is set up as a multiplication problem. It's this times that. So what this means is if x minus 4 is equal to 0, if this whole parenthesis is equal to 0, 0 times this, no matter what this comes out to be, would always equal 0. If I figure out what would make this parenthesis equal to 0, whatever this would be times 0 is still going to give me 0. So again, I need to figure out what x value would make this entire parenthesis equal to 0, and I need to figure out what x value would make this entire parenthesis equal to 0, because if either of them are equal to 0, 0 times anything is always going to give me 0. So this is as simple as just taking each parenthesis and setting them equal to 0. So I would take x minus 4, set it equal to 0, and take the x plus 2 and set it equal to 0. For the first one, I would just add 4 to this side, so x would equal 4. For the second one, I would just subtract 2 from both sides, and x would equal negative 2. By substituting the 4 back in, if I put 4 here, 4 minus 4 is 0, so it'd make this parenthesis equal to 0. 0 times this, if I put 4 into here, I'd get 4 plus 2 is 6, but this parenthesis was still equal to 0, so 0 times 6 is 0. So I know that x equals 4 is one of my answers. If I put negative 2 in, negative 2 minus 4 gives me negative 6, but when I put negative 2 in here, I get negative 2 plus 2, which is 0, and the negative 6 times 0 is still going to give me 0. So again, we had an equation set equal to 0. The equation was turned into a multiplication problem for us. So in that case, we just take each term and set it equal to 0. Applying that same idea to problem B, we have x minus 5 times x minus 1 equals 0. So again, I have a product set equal to 0. So if I figure out what x value makes this parenthesis equal to 0, my entire equation would be equal to 0. And if I figure out which x value makes this parenthesis equal to 0, the entire equation would equal 0. So again, it's just a matter of taking x minus 5, setting it equal to 0, and taking the x minus 1 and setting it equal to 0. So all I would do is add 5. So I get x equals 5. And in the second one, I would just add 1. So I get x equals 1. And again, quickly substituting this back in, if I put 5 in up here, 5 minus 5 is 0, 5 minus 1 is 4, but 0 times 4 is still 0, so that's one of my answers. And then if I put 1 in, 1 minus 5 is negative 4, but 1 minus 1 is 0. So negative 4 times 0 is still going to give me 0. So I have two answers, x equals 5 and x equals 1, just like I had two answers in this problem, x equals 4 and x equals negative 2. For problem C, it says, why does this type of equation have two solutions? Well, the reason why we had two solutions was because we had two terms, two parentheses that both had x in them. And if I were to actually multiply these out, I would take x times x and I would get x squared. So whenever I have a power of 2, when I multiply this all out, I would have two answers. So again, why does this type of equation have two solutions? Because if we were to multiply the left side of the equation out, the highest power would be x squared. Because again, x times x is x squared, just like over here, x times x is x squared. So we'd have a power of 2. So if the highest power is 2, then we would have at most 2 answers. If the highest power was 3, then we would have at most 3 answers. If the highest power is 4, at most we would have 4 answers, etc. Part D. How could you use the zero product property to solve the following polynomial? So we have 4x to the fourth plus 24x to the third, and notice it is set equal to 0. Remember, to use the zero product property, you first have to have your equation set equal to 0. Next, in order to use the zero product property, we need to turn the problem into a product or a multiplication problem. And the way we do this is by undoing the distributive property. So think about it like this. If I have 4x to the fourth and 24x to the third, I need to think about what is the biggest number that goes into 4 that also goes into 24. And in this case, that would be 4. Then I would take the x's. I have x to the fourth here and x to the third here. I take out the smallest number, which would be x to the third. So I got to figure out what do they have in common. This is called the greatest common factor. So the biggest number that goes into 4 and 24 was 4, and then how many x's did they have in common? I had x to the fourth and x to the third. I could take out 3 x's out of here, but I could not take 4 x's out of here. So you always take out the smallest power. After taking both terms out, I then multiply by what's left over. So I would do 4 times what would give me 4, which would just be 1. So you could put a 1 down there, but it's not necessary. And then x to the third times what would give me x to the fourth. I just need 1 more x. And look at the second term now. 4 times what would give me 24. 4 times 6 gives me 24, and then I took 3 of the x's out. I only had 3 to begin with, so then I'm just going to close the parenthesis and set it equal to 0 like it was originally. So notice we just undid the distributive property. So if I were to multiply this back out, 4x to the third times x would be 4x to the fourth, and 4x to the third times 6, 4 times 6 is 24, then I would just have x to the third. So again, I just take out the greatest common factor, multiply by what's left over, and therefore now I have my equation as a multiplication problem. 4x to the third times x plus 6. So I could now take 4x to the third, set it equal to 0, just like we did in problems A and B at the top. And I could take the x plus 6 and set it equal to 0, just like we did at the top. So thinking about it this way, 4 times what would give me 0? Well, if x was equal to 0, 4 times 0, even if it's 0 cubed, is still going to give me 0. So in this case, it would be x equals 0. And in the second case, what plus 6 would give me 0. So basically, you just subtract the 6, so I get x equals negative 6. So my two answers are x equals 0 and x equals negative 6. This process is called factoring. So again, it's called factoring because 4x to the third and x plus 6 are factors of this equation. Just like x minus 4 and x plus 2, if I were to multiply that whole equation out, these would be factors of that polynomial. And x minus 5 and x minus 1, if I were to multiply that out, those would be factors of that polynomial. A factor just means that I can take that times something else and get that equation or that polynomial. So again, this process of breaking it down into a multiplication problem is called factoring. And that's how we're going to approach all of our problems from here on out. Now let's look at example number 2. It says solve each of the following. So remember, we're going to be using the zero product property. So the first thing you need to do is make sure that your equation is set equal to 0. Ours are, for both of the problems actually. Always set it equal to 0 first. Next, we need to turn it into a product. which just means in this case, we're going to look for the greatest common factor. So look at the numbers first and the variable second, just kind of like we did when we were multiplying everything out in the first 3 sections. We took care of the numbers and then we took care of the variables. It's exactly what we're going to do here. So look at the numbers first. What's the biggest number that goes into 2 that also goes into 8? In this case, it would be 2. And then look at the x's. What x's do they have in common? I have 2 x's here and 1 x here. Basically, you're just always going to take out the smallest power, because I could take an x out of x squared, but I couldn't take 2 x's out of just x. So always take out the smallest power. So then I'm going to multiply by what's left over. So just think about it like kind of like division. 2 times what would give me 2, which is just 1. So you could put a 1 in here, but it's not necessary. And then I took an x out. I had 2 x's to begin with, so I have 1 left over. Next, I'm going to figure out 2 times what would give me 8. 2 times 4 gives me 8. I took the x out. I only had 1 to begin with, so I'm just going to close the parenthesis and set it equal to 0. So now I have it as a 0 product, so I'll apply the 0 product property. So I will do 2x equals 0 and x plus 4 equals 0. So in this case, I would just divide by 2. My first answer would be 0. So if I plug 0 back in, 2 times 0 is 0. So then I would do 0 times, well here, 0 plus 4 is 4. So 0 times 4 is 0. So there's our first answer. Next, I would take 4 and subtract from both sides. So I'd get x equals negative 4. Plugging that back in, 2 times negative 4 is negative 8, but negative 4 plus 4 is 0, and negative 4 times 0 is going to give me 0. So my 2 answers were 0 and negative 4. I knew I was going to have at most 2 answers since the highest power was 2 in my problem. Now let's look at part B. A squared plus 5a equals 0. So this problem's a little bit different because in a problem like problem A, I had a 2 and an 8, and the biggest number that goes into both of those is 2. But notice how a squared doesn't have a coefficient. If there is no coefficient in front of one of your terms, there is no number that goes into that coefficient and the coefficient over here. So in this case, our greatest common factor is just going to be a variable. So if I have a squared here and a here, the smallest power is just a. So I'm going to take an a out, and I'm going to multiply by what's left over. So think about it like this. A times what would give me a squared? A times a would give me a squared. Next, a times what would give me 5a? So I would just need a 5. Set it equal to 0. So now that I have it as a 0 product, I'm going to take each term and set it equal to 0. So I have a equals 0 and a plus 5 equals 0. There is nothing to do with this first part, so a equals 0 is just my first answer. And if I think about putting it back in, 0 times 0 plus 5 is 5, 0 times 5 is 0. For our second part, we would subtract 5 from both sides. 0 minus 5 is negative 5. If I think about putting that back into our problem, negative 5 would go here, negative 5 plus 5 is 0, negative 5 times 0 is 0. So I have 2 answers just like I thought I would have since my highest power was squared originally in my problem. On to example 3, solve each of the following. So it's just more of the same. So part A says 3s squared minus 9s equals 0. So again, always make sure your equation is set equal to 0. Look at the coefficients first. What's the biggest number that goes into 3 and into 9? So I would just have a 3. And then look at your variables. I have s squared here and s here. Always take out the smallest power, so I'd have 3s, and then I'm going to multiply by what's left over. So here, 3 times 1 would give me 3, so I don't really need to put that 1 there. And then s times s would give me the s squared here. Then I would have 3 times what gives me the negative 9. 3 times negative 3 gives me negative 9. I took the s out, so I have nothing left over here, so I'm going to close the parentheses and set it equal to 0. Now that I've set it up as a 0 product, I'm going to take each of the factors and set them equal to 0. So I have 3s equals 0 and s minus 3 equals 0. So the first part, I would divide both sides by 3, and I would get s equals 0. The second part, I would add 3 to both sides, and I would get s equals 3. Those are my 2 answers. If I plug them back in, I would get 0 times something is equal to 0. And the second part, I would get something times 0 equals 0. So I know it would work. I knew I'd have 2 answers because my highest power was s squared. For problem B, this problem looks a little bit different because notice that the equation is not set equal to 0. So remember, in order to use the zero product property, you have to have your equation set equal to 0. So this is just as simple as subtracting this 6k from the left and the right, because 6k minus 6k is 0, so that gives me 0 on the right-hand side, and 3k squared minus 6k is just that, 3k squared minus 6k, since k squared and k are not like terms. So now that I have the equation set equal to 0, now I need to turn it into a product. So I need to think about what's the biggest number that goes into 3 and 6, and how many k's will I take out. So the biggest number that goes into 3 and to 6 is 3, and then k squared and k, remember you basically just take out the smallest power, so I'm going to take out the k. So then just multiply by what's left over. So parentheses, 3 times 1 would give me 3, k times k would give me k squared, and then 3 times what would give me negative 6, so it'd be 3 times negative 2. I took the 1k out, I only had 1k to begin with, so then I'll close the parentheses and set it equal to 0. So now that I have it as a 0 product, I'll take each of the factors and set them equal to 0. So I have 3k equals 0 and k minus 2 equal to 0. So I'll divide both sides by 3 for the first problem, so k equals 0. And the second problem, I would add 2 to both sides, so I'd have k equals 2. If I quickly plug those back in, I would always get 0 times something equals 0, or something times 0 gives me 0. So again, I have 2 answers because my highest power was 2, just like I knew I should have. And as if this section couldn't get any harder, let's throw some story problems on top of it. First, let's define a projectile. A projectile is an object that is propelled into the air but has no power to keep itself in the air. So let's think of some examples here. So anything that you can throw into the air, like a basketball, a tennis ball, a baseball, anything like that. How about you just jumping in the air? Any type of animal, anything that can jump in the air, that would also be considered a projectile, because once you jump up, you always have to come down because there's nothing behind it to keep you in the air. And finally, just think of those toy rockets that you can blast off. You can propel it into the air with as much force as you can, but there's nothing to keep it in the air, so that rocket would be considered a projectile. The height of a projectile can be described by the vertical motion model. And the vertical motion model is as described below. The height h in feet of a projectile can be modeled by negative 16t squared plus v times t plus s equals 0, where t is the time in seconds. So again, we're working in feet and in seconds. The object has been in the air. V, this v right here, is the initial velocity, and velocity is just a fancy word for speed. So basically how fast it's initially going, and that's going to be measured in feet per second, so kind of like miles per hour, but feet per second. And s is the initial height. So I don't know why they use s for the initial height, but this variable right here represents how high off the ground it initially is. So if you're jumping off a building onto the ground and the building is 20 feet in the air, s would be 20. So again, keep in mind that we're going to use this equation anytime we're talking about a projectile. And we're always going to work in feet and seconds. If you're working in a different unit of measurement, this equation would change. So this is only used if we're talking about feet and seconds. So now let's apply the vertical motion model to example number 4. A startled armadillo jumps straight into the air with initial vertical velocity of 14 feet per second. After how many seconds does it land on the ground? So we need to use the vertical motion model, which is negative 16t squared plus v times t plus s. So let's start plugging in things that we know. It says that it jumps straight into the air. So its initial height, s, would equal 0. And it says its initial vertical velocity is 14 feet per second. So v equals 14. And then it says after how many seconds does it land back on the ground? So we're going to set it equal to 0 because when it's landing back on the ground, he's back at 0 feet off the ground. So we're going to set it equal to 0. So what we're going to end up doing, since it says after how many seconds, we're going to be solving for t. So let's start plugging these numbers in. We would have negative 16t squared plus 14t. We could put plus 0 in here, but we don't really need to because that would just be redundant. And we're going to set it equal to 0 because, again, when it says after how many seconds does it land on the ground, it would be back on the ground at a height of 0. So that's why we're setting it equal to 0. So we have a 0. Now we need to turn this into a product so we can apply the 0 product property. So the first thing we're going to do is figure out what's the biggest number that goes into negative 16 that also goes into 14. So the biggest number that goes into 16 and 14 is 2. And typically, this is not what you always have to do, but typically, if your first number is negative, a lot of times you're going to take a negative number out with that greatest common factor. They also have a t in common, since there is a t squared here and a t here. So again, I'm going to take a t out. And again, you do not have to take this negative sign out. It's just kind of common that if the first number is negative, even if the second number isn't negative, that you take a negative number out. I don't know why that is, but that just kind of, math is its own language. It does its own stuff. So that's what typically mathematicians do. But again, it's not required. So let's start figuring out what would be left over in the parentheses when we take that negative 2t out. So in parentheses, we're going to multiply by what's left over. So negative 2 times what would give me negative 16? That would be 8. So negative 2 times 8 is negative 16. I took a t out. I had 2 t's to begin with, so I have a t left over. And then now I need to figure out what would be left over with the 14t. So negative 2 times what would give me 14? Negative 2 times negative 7 would give me positive 14. I took the t out. I only had 1 t to begin with, so I am done, and I would close the parenthesis. Set it equal to 0. So now that I have it as a 0 product, I'm going to take each factor and set them equal to 0. So I would take negative 2t, set it equal to 0, and take the 8t minus 7 and set it equal to 0. So the first part, I would divide both sides by negative 2, and t would equal 0. My second part, I would add 7 to both sides. So I'd have 8t equals 7, and then divide both sides by 8. So then t would equal 7/8. So think about the question that we were being asked. It says, after how many seconds does it land on the ground? So we got two answers, t equals 0 and t equals 7/8. So do you think that it took the armadillo 0 seconds to go up and come back down? No. Did it take the armadillo 7/8 of a second to go up and go down? Yes. So again, you could leave your answer as 7/8, but you could turn that into a decimal. It doesn't really matter. But to answer the question, it would take 7/8 of a second for the armadillo to go up and to come back down. That's it for this section. Make sure you jot down anything you didn't understand that we can go over in class, and we'll see you then.